Hello students, welcome to today's lesson. I am Brook Alamu. Today we are going to discuss about the new chapter, some elements in chemistry and industry. From this chapter, discuss about a number of definitions, the definitions for industry, the extractions of different elements like sodium, calcium, tin, zinc, silicon, chromium, also the use of different compounds like ammonia, nitric acid, sulfuric acid, DAP, and so on. This is the new chapter, grade 12, unit 5. Okay, let's continue. Some elements in chemistry and industry. There are 118 elements known at present. 92 elements occur in nature, the rest man-made or artificial. Therefore, about 118 elements, 92 elements occur in nature, the rest are man-made. Elements that are found in the periodic table classified as metal, non-metal, and metalloids. Please students, look this periodic table. Look, this is the modern periodic table. This periodic table contains different elements. You know, in the periodic table, there are 7 periods and 18 columns. Therefore, this is group 1 elements. Again, this one is group 2, all alkaline earth metals. Group 1 and group 2 elements are metals, except hydrogen. This is transition elements. Transition elements generally metals. Again, this is inner transition elements. Inner transition elements, again, metals. This is, by the way, p-block elements. P-block element. P-block elements generally non-metals, because some p-block elements are metals, like aluminum. Therefore, this is the general periodic table classifications of elements. From this periodic table, 92 elements exist in nature. The other one is man-made or artificial. This is S-block element, metals, except hydrogen. This is D-block element, again metal. This one is F-block element, again metal. This one is P-block element. Generally, P-block elements are non-metals. From this periodic table, 70% is metals, 20% is non-metals, and the remaining 5% are metalloids. Therefore, in the periodic table, elements classified into how many types? 3 types. One is metal, approximately 70%. 2, non-metal, approximately 20%. The remaining 5% are metalloids. This is a metalloid positions like gallium, antimony, polonium, and so on. Therefore, this is all about the classifications of elements in the periodic table. Okay. Therefore, in the periodic table, elements classified as metal, non-metal, and metalloid. A solid substance that occurs naturally in the Earth's crust is called mineral. A solid substance that occurs in nature is known as what? It is a mineral. All minerals are not suitable for the extractions of elements. All minerals are not suitable for the extractions of elements. Minerals from which elements can be extracted easily and economically is called ores. Why? Because all elements are not easily extracted. Elements extracted from mineral easily and economically is called ores. Therefore, a solid substance naturally exists is known as mineral. All minerals are not suitable for the extractions of the element. But when elements extracted easily and economically is called ores. Therefore, all ores are minerals. But all minerals are not ores. Why? Because all elements are not suitable for the extractions of the elements. The other point is the occurrence of elements. The 12 most abundant elements in decreasing order of their abundance are, the first one is oxygen. In the Earth's crust, the most abundant element is oxygen. You know oxygen is non-metal. The second one is silicon. You know silicon is metalloid. The third one is aluminium. Aluminium is metal. The fourth one is iron. The fifth one is calcium. The sixth one is sodium, and so on. This is in decreasing order of the most abundant elements in the Earth's crust. But the most abundant element in the Earth's crust is oxygen, but it is non-metal. The second most abundant element in the Earth's crust is silicon, which is metalloid. The third most abundant element is aluminium, it is metal. Students, what is the most abundant metallic element in the Earth's crust? What is the most abundant metallic element in the Earth's crust? Yes? Thank you. The answer is aluminium, because oxygen is non-metal, silicon is metalloid, aluminium is metal, therefore aluminium is the third most abundant element in the Earth's crust. But the most abundant element, metallic element, is aluminium. The second most abundant metallic element is iron, calcium, and so on. This is the abundance element in the Earth's crust. In the atmosphere, the dominant one is nitrogen, 78%. Nitrogen exists in two forms. Nitrogen is inert. Therefore, the second one is oxygen, 21%, carbon dioxide, 0.035%, argon and other elements in trace amounts. Very few elements exist in free or native states. In free states. In free states or native states means cannot affected by air and water. Like gold, silver, platinum, palladium, ruthenium, and osmium generally found in free states. Remember, silver, gold, platinum, palladium, ruthenium, and osmium exist in free states because of less reactivity, because this is not affected by air and water. But most metals occur in combined forms because of its reactivity. In the forms of what? In the forms of oxides, carbonates, sulfides, sulfates, silicates, chlorides, nitrates, phosphates, and so on. This is all about because of the reactivities of the elements. Some of these common ores exist in the forms of compounds like oxide, in the forms of oxide like hematite, the ore of iron, magnetite, another ore of iron, corundum, casterite, the ore of tin, quartz, silicon dioxide, zincate, cuprite, bauxite, rutile. This is all about some of the ores of different elements, but in the forms of oxide. In the form of sulfides, like lead sulfide, galena. By the way, galena is the main ore of lead. Iron pyrite, it contains sulfide. Zinc blende, the ore of zinc, exists in the forms of sulfides. Halide, you know halide, halogens, in the forms of chloride, common salt, sodium chloride, rock salt, calcium chloride, exists in the forms of halides because of its reactivity. The other one is in the forms of carbonates, because elements exist in the forms of different compounds like oxide, like chloride, like halide, like carbonate. Carbonate, for example, dolomite. Dolomite is a combination of magnesium carbonate and calcium carbonate. Limestone, chalk and marble. By the way, limestone, chalk and marble, the same chemical formula, calcium carbonate. The only difference is hardness. Sulfates, barium sulfate, calcium sulfate with water, gypsum, exists in the forms of sulfates. Please, students, try this question. Explain why some elements exist free in nature, while others exist in the forms of compounds. Thank you. the main reason for some element exists in the forms of compound. The other element exists in the forms of compound. One is exists in the forms of elemental form or in free state. The other one exists in the forms of compound. The main reason is what? Because of their reactivity. The only difference is reactivity. Elements exist in the form of compound or in free states depends on their what? Depends on their reactivity. The most reactive element exists in the forms of compound, like oxide, sulfate, sulfide, and so on. The least reactive element exists in the free state, like platinum, palladium, ruthenium, osmium, and so on. Therefore, the reason is why, because of its reactivity. The most reactive element exists in the forms of compounds, in different compounds, and the least reactive element exists in free states. Question number 2. Which of the following is the second most abundant metallic element in the Earth's crust? Which one is the correct answer? Which of the following is the second most abundant metallic element in the Earth's crust? Aluminium, oxygen, iron, or silicon? First, aluminium is metal, oxygen is non-metal, iron is metal, already transition element, silicon is metalloid. The question is, which of the following is the second most abundant metallic element? Therefore, oxygen is not the answer. Silicon is not the answer. What is the most abundant element? Oxygen. The second, silicon. The third, aluminium. The fourth, iron. The fifth, calcium, sodium, and so on. Already non-metal. This is metalloid. This is metal. Therefore, the first or the most abundant metallic element is aluminium. But the question is, the second most abundant metallic element. The second most abundant metallic element is what? Aluminium or iron? Iron. Therefore, the answer is choice C. Question number 3. Which of the following metal exists in free state, in native states? Pt, platinum, Mg, magnesium, Na, sodium, K, potassium. Which one exists in free states? Yes? Thank you. The answer is platinum, because platinum does not affected by air and water. Because of less reactivity, platinum exists in free state. Some elements in industry. Metallurgy. Metallurgy is the science and technology extracting metals from their natural sources and preparing them for practical use. The principal steps that are carried out to obtain metal from its ore are concentrating the ore, pretreatment, extracting the metal, and refining. The first point is concentrating the ore. Concentrating on ore increases the fraction of metal-bearing, metal-containing elements. Metal-bearing or, ore from mineral elements, easily and economically extracted is known as ore. Ore contains what? Metallic element, also some impurities. But that metallic elements can be extracted. The ores can be removed, is concentrating the ore. Concentrating on ore increases metallic containing elements by removing some unwanted materials. This unwanted material, like soil, like rock, like different types of undesired materials are known as gunk. Therefore, by eliminating most of the combining rock, soil, different unwanted materials collectively known as gunk. Therefore, concentrating the ore means by removing the gunk increases the metal-bearing element is known as concentrating of the ore. A gunk is what? It is undesired, not desired, undesired material. Undesired material means what? It is impurities. Impurities which found together with what? The ore. Because ore contains element plus unwanted materials. These unwanted materials, like rock, soil, is called gunk. Therefore, the ore must first be finely divided by crushing and grinding, and the gangue can be removed a number of ways. The first one is gravity separation. Gravity separation is a method of separating an ore from its gangue based on density differences, by using of density difference. For example, gold. Gold with its impurity extracted by gravity separation. Why? Why gold can be used from this case? Because the density of gold is very high, 90.3 gram per milliliter. This is the density of gold. This gravity separation is applicable for density differences. Density differences between the mineral and the gangue. The mineral means that contains the ore, based on their density difference. The second one is magnetic separation. Magnetic separations are applicable for magnetic substances and non-magnetic substances, separated by magnetic separation, like ferromagnetic substance from their impurities. For example, magnetite, the ore of iron. Magnetite, Fe2O3, the ore of iron, is separated from its gangue using a magnet. Therefore, magnetic separation is another technique. The third one is froze flotation. Froze flotation, especially for sulfide ores. Sulfide ores. It is applied based on their solubility difference. You know solubility, polar, non-polar, and so on. Based on their solubility difference. Gravity separation based on density difference. Magnetic separation based on their what? Magnetic substance and non-magnetic substance. The third one is what? Froze flotation. Froze flotation based on their solubility difference. Polar with polar, non-polar with non-polar. You know, like dissolves like principle. And it is gangue with oil and detergent. For example, sulfide ores. The very important method for froze flotation is sulfide ores. Sulfide ores, by using of oil and detergent, can be separated by using of flotation technique. The fourth one is amalgamation. Students, you know amalgam? You know in chapter 1, what I mean by amalgam means? Amalgam means a combination of mercury with other metal, or mercury with other metals, is known as amalgam. The process is amalgamation. Therefore, an amalgam is an alloy of mercury with another metal, or mercury with another metals. Mercury forms amalgam with a number of metals, and can be used to extract these metals from their ores. Gold and silver extracted by using of this method, by using of amalgamation. The fifth one is leaching. Leaching is a chemical method. Leaching is different from the above 4 methods of concentrating the ore. Why? Because leaching is by using of chemicals. The 4, like gravity separation, magnetic separation, froze flotation, and amalgamation, is not chemical method. It is a physical process. Leaching is a chemical process, when elements are extracted by using of chemicals. Because of that, leaching is a chemical method of concentrating ores. For example, gold and aluminium are concentrated by leaching, by using of chemical. The element gold extracted by using of chemical. The element aluminium by using of chemicals, like sodium hydroxide, by adding of sodium hydroxide, and so on. Finally, it gets aluminium. Look one example here. Gold. Gold is sometimes found in ores in the elemental states, but it usually occurs at relatively small concentrations. A process is called cyanidation. The extraction, the final process, a cyanidation process. Look, this is gold, students. This is gold, Au, the symbol of gold. But this gold is impure. Impure gold. Impure gold treated by aqueous solutions of cyanide. AQ means aqueous. Aqueous solution of cyanide in the presence of air, oxygen. Finally, it gives gold complex. This is a gold complex. AuCN2-. This is gold complex. Gold complex formed by what? gold, impure gold, treated by an aqueous solution of cyanide in the presence of oxygen or air. Finally, it gets gold complex and hydroxide ion. This gold complex treated by or reacted by zinc powder. Zinc powder. Finally, it gets gold. This gold is pure. Pure gold, impure gold. This process is known as cyanidation. Why cyanidation? Because of the addition of aqueous solutions of cyanide. Because of the chemical cyanide, leaching is an example of a chemical method. The second one is pretreatment. The first one is concentrating the ore. The second one is pretreatment. Pretreatment means converts non-reduced substance to a reduced substance. Converts a mineral to form that is easy to reduce. For example, sulfides are converted to reducible oxides by heating in dry air. A process is called roasting. Roasting means sulfide converted into oxide by using of oxygen. It is known as roasting. Look, this is sulfide. Sulfide ore. Sulfide ore treated by oxygen by using of heat, it produces lead oxide. Lead sulfides are not easily reduced, but lead oxides are easily reduced. Zinc sulfides are not easily reduced, but zinc oxides easily reduced. What is the main important point here? Non-reduced substance like lead sulfide, like zinc sulfide, converted into oxide. Lead sulfide, lead oxide. Zinc sulfide, zinc oxide. By using of what? By using of heat, by using of O2. Therefore, non-reduced substance converted into reduced substance, a mineral easy to extract. This is known as pre-treatment. Sulfide converted into oxide is what? Known as roasting. The third one is production of metals. The production of metals by reduction may be accomplished either chemically or electrolytically. In chemically, a more electropositive metals can be used as reducing agents to separate a less electropositive metals. A more electropositive metals can be used to extract a less electropositive metals. For example, look at these reactions. This is chemical reduction. V2O5, vanadium pentaoxide. TiCl4, titanium tetrachloride. Cr2O3. Now, V, vanadium, Ti, titanium, Cr, chromium. By the way, all are transition elements. Vanadium, titanium, chromium is transition elements. V2O5 treated by what? Calcium. Students, which one is more reactive? Calcium or vanadium? Calcium is more reactive. Because of calcium more reactivity, calcium replaced vanadium. Therefore, vanadium pentaoxide treated by calcium, it gives vanadium. Therefore, to get vanadium, by using of what? By using of a more active element, calcium. Here, titanium tetrachloride with what? Magnesium. Why used magnesium? Because magnesium is very reactive element than titanium. Therefore, magnesium replaced titanium, titanium are formed. Again, chromium by aluminium, because aluminium is more reactive than chromium. Aluminium replaced chromium, finally chromiums are formed. Therefore, a more electropositive metals can be used to form a less electropositive metal atoms. The first one is in chemical. The second one is electrolytical reduction. Electrolytic reduction is suitable for highly electropositive metals. This one is suitable for what? Like alkali metals, alkaline earth metals, and aluminium. Therefore, such as sodium, magnesium, and aluminium are extracted by using of electrolytic reduction. You know, in chapter 4, electrochemistry. In electrochemistry, positive ions and negative ions. For example, sodium chloride. In sodium chloride, positive ions are migrated to the anode, negative ions are migrated to the anode, because ions are usually migrated to oppositely charged electrodes by using electrolysis process. This one is known as electrolytic reduction. In the electrolytic or in the electrolysis at the cathode, metal ions, yes, because in electrolytic cell, cathode is negative electrode. Metal ions are attracted to the negative electrode. The other one, and reduced anode in electrolytic cell, anode is positive. Anion, negative ion, is attracted to anode is positive electrode. Anion means negative ion. Negative ions are attracted to anode and easily oxidized. The fourth one is refining and alloying. This one is metals prepared by reduction usually need further treatment to remove impurities. This is further treatment. The three common purification procedures are distillation, electrolysis, and zone refining. Distillation, metals that have low boiling points such as mercury, magnesium, and zinc can be separated from other metals by fractional distillation because of their low boiling point. This one is based on their boiling point. The second one is electrolysis. Students, you know what I mean by electrolysis, already discussed in chapter 4. The last one is zone refining. Is a method used for obtaining highly purified metals. To get highly purified metals uses zone refining. The impurities have higher solubility in the molten states as compared to that of in the solid states. Therefore, this zone refining is a method used for obtaining highly purified metals. In order to obtain metals like silicon, the symbol Si, gallium, Ga, germanium, Ge, tellurium, Te, is used for zone refining, like silicon, tellurium, gallium, and germanium. In highly pure form, refining is carried out by zone refining. This is all about the concentrating of the ore. Extraction, properties, and uses of some selected metals. The first one is sodium. Extraction of sodium. First, sodium, the symbol is Na. Sodium is atomic number 11. Sodium is configuration 281 or 1s2, 2s2, 2p, 6, 3s1. Therefore, sodium is S block element. Sodium is 1 valence electrons. The sodium is very reactive element. Because of its reactivity, sodium never found free in nature. Is a very reactive metal and is not found free in nature. Because of its reactivity, sodium stored in a paraffin oil. It exists in the forms of what? Compound. Sodium exists in the forms of compound. Sodium is obtained by the electrolysis of molten mixtures of about 40% sodium chloride, 60% calcium chloride in the down cell. The extraction of sodium, it uses the compound is what? Sodium chloride. Why we add calcium chloride? Because it lowers the melting points of sodium chloride. Because calcium chloride is added to lower the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius. Therefore, the purpose of calcium chloride is what? To decrease the melting points of sodium chloride. The sodium metal formed at the cathode and chlorine gas formed at the anode. You know this one. Sodium chloride in the molten state, sodium plus and chlorine minus. Anode, oxidation occurs. Cathode, reduction occurs. Anode is positive electrode. Cathode is negative electrode in electrolytic cell. Therefore, ions are usually migrated to oppositely charged. Positive ion migrated to cathode. Here, sodium plus, chlorine minus here. From chlorine minus, Cl2 can be formed. From sodium plus, sodium can be formed. This one is 2 plus 2 electron because oxidation. This is 1 electron, but oxidation half reaction electron and reduction half electron must be balanced. Therefore, this one is multiplied by 2. Finally, it gets 2 sodium plus 2 chlorine minus. It gives Cl2 gas and sodium can be formed. Therefore, the sodium metal formed at the cathode. Yes, sodium metal is formed at the cathode. Chlorine gas formed at the anode. Chemical properties of sodium. The first one, reaction with water. Sodium react with water, sodium hydroxide plus H2. Sodium hydroxide, basic. By using soft indicator like phenolphthalein, pink color can be formed and hydrogen gases are evolved. Therefore, sodium react with water, it gives sodium hydroxide and H2. The other one, sodium react with air, oxygen. Sodium react with air, oxygen, 2 products can be formed. 1, sodium peroxide. 2, sodium oxide. Sodium peroxide is major product. This one is a major product. This one is a minor product. 3 or C, reaction with hydrogen. Sodium reacts with hydrogen, it produces sodium hydride. Therefore, this is sodium hydride. D, reaction with halogen. Halogen group 7, like fluorine, chlorine, bromine, and iodine. Therefore, sodium reacts with fluorine, sodium fluoride can be formed. Sodium reacts with chlorine, sodium chloride can be formed. Therefore, sodium reacts with water, sodium reacts with oxygen, sodium reacts with hydrogen. Again, sodium reacts with halogen. This is because of reactivity. Finally, the use of sodium. Liquid sodium metal is used as a coolant. Liquid sodium is very important as a coolant for nuclear reactors. Again, sodium vapor, sodium in the forms of gas, used in street lights and produces a brilliant yellow color. Finally, sodium is very important for the proper muscle and nerve function. This is all about the extraction, the uses and chemical properties of sodium. Student, this is all about today's lesson. In today's lesson, discuss about the new chapter. In the next class, discuss about other elements in the forms of extraction, uses, properties, and so on. Until next time, goodbye, students.